Hello friends, welcome to my channel Economica. I, Dr. Gopal B. Saraswat, welcome you all. Today the topic for discussion is chi-square test. This is a test which is from a non-parametric test. In today's video, I am going to answer when to use this chi-square test, what are the different application of chi-square test, why it is considered under a non-parametric test, what are the different advantages, disadvantages, and finally how to use chi-square test on a data set using SPSS. So let's start the video. First question is when to apply. We have two types of variables, independent and dependent variable, but the condition is when both are categorical variables, then only you could apply chi-square test. Categorical in the sense that they have a category of responses, category of answers. So independent variable, for example, let's say we have a independent variable like gender, where we have a male and female as the two categories. Dependent variable is like smoking habits. So we have a category like the smoker is a person is a non-smoker, current smoker, or a past smoker. So when we have a two category variables, one is independent, one is dependent, we come across such a situation, then only we could apply a chi-square test. There are different distribution families: normal distribution, T distribution, F, and chi-square distribution. And each family of distribution have its own characteristics. When chi-square is the only member of this distribution family which is comes under the non-parametric test. I also discuss which test to apply in my last video in hypothesis testing, which statistics test to apply and when. You could watch that video for detailed parametric and non-parametric test analysis. So when we discussing about when to apply the chi-square test, the first condition comes here is when population is not normally distributed. When your population is not normally distributed, you could not rely upon the parameters like mean, standard deviation, and proportion, and therefore you have to use a non-parametric test. When your data is extremely skewed, then also you could apply a chi-square test, because this test is distribution free test. This test do not require any assumption regarding the shape of the population or a sample. It could be a non-normal, and therefore you could apply this chi-square test as a non-parametric test. The advantage of this non-parametric test of chi-square is this test could be applied in any rigid situation, does not require a data set or population to follow a normal distribution. When resulter encounter with an application of numeric observation, and it is very difficult to calculate the rank, suppose you are not able to calculate the rank of something, or sometime you are only able to calculate rank but you are not having the absolute value of that particular variable. In such situation where only rank or categories are available, then you could apply a non-parametric test chi-square. For example, it is easy to obtain a rank for a preference of consumers, and if such a case, you could apply a chi-square test on these ranks. Another advantage of this test is can be applied on nominal and ordinal data, because both types of data have a different characteristics and they lack comparable numerical value or exact or absolute value. For example, if you ask the religion of population, it will be categorized as Hindu, Sikh, Christian and Muslim. This is the nominal scale data, but this is having a category. So in such scenario, you could use a non-parametric text to analyze, and that is one is chi-square. Disadvantage is because of using category based data set or the variable, you are avoiding and you are not looking to go in depth analysis. This means that your data set have a many uh, details, but as you just focusing upon the categories only, therefore the many information seems to be a wasted one, and that is one the disadvantage of non-parametric test. And another disadvantage is the null hypothesis in case of non-parametric test are loosely structured, and because of which you are not able to have a hypothesis which is well defined and well structured. So this is another disadvantage of it. When we compare parametric test assumptions and application with non-parametric test, we are just very much clear that normality is an assumption for parametric but not for non-parametric. When it comes to the sample size, the non-parametric test generally being used on a small sample size generally, but as the software has now been updated and we have progress in the level of calculation using softwares, so we are able to use these non-parametric tests on large sample as well. When it comes to the application part, Z and T tests generally being used along with ANOVA in parametric tests. But here we use generally the non-parametric test. The detail is still available with you in my last video. So here we generally use a non-parametric test as a chi-square. Properties of chi-square distribution. This is unlike a normal and T distribution. This chi-square distribution is non-symmetric. This seems to be a not normal, and therefore it is being known as non-parametric test. The value of chi-square are always greater than or equal to 0, and the shape of chi-square distribution depends upon the degree of freedom. With the increase in the degree of freedom, distribution tends to become normal, and that is the characteristics of chi-square. The application of chi-square is in three instances or three cases. First, you want to check the goodness of it, or you can say the association of two different variable, independent with the dependent variable, how well both are fitting with each other. Secondly, the chi-square test also try to find out whether variables are independent or not. And the third, whether two population proportions are equal or not. So these are the three application of chi-square test. This is the formula for chi-square test, where you have observed values, expected values. So when you deduct observed minus expected, and then you divide it by the expected and take a sum of these squared values, that brings you the chi-square value. This purely depend upon the k minus 1 degree of freedom. This is the chi-square distribution table, and using this chi-square distribution table you can compare calculated value of chi-square with the table value of chi-square. If your calculated value of chi-square is less than the table value of chi-square, your null hypothesis is accepted. Otherwise, you could reject the null hypothesis. So Now let's have a practical of chi-square test. We conducted a survey and where we have around 435 respondents. We have a two variables. One is gender, where we have a male and females, and the smoking habit of the people. So some are non-smoker, some are current smoker, and some are saying they are past smokers. So what we are trying to find out whether is there any association of gender with the smoker. So first thing is association. Let's check whether gender is a deciding factor of smoking habit, or being a male or female may have a different characteristic being a smoker or non-smoker. So this is the first association we are trying to find out here. And second thing we are trying to find out is strength of that association. How well that association is. This is the strong association, strength is strong, moderate, or very weak. That is what we are trying to find out. So let's do that using SPSS. Here you can see we have a two variables. One is gender, another is smoking habits. You can see this is the data set. Male and female is in my gender. The total data set we have having, that is around 435, as I said. These are the total number of respondents we have under this study. When I go to the variable view, you can see that these are the two variables, and the question was what is your gender, and second is are you a smoker or not. So this is how we have. So how to apply chi-square test? So what we want to know, I'm again just giving you the uh, focus point, and that is the first thing we want to know is whether gender and smoking habit is associated with themselves each other, that is mean association. And second we want to check is whether this association is having any strength. So these are the two factors we would like to analyze using the chi-square test. So let's do that. First you go to analyze, go to descriptives. Here you have a fourth option called cross tabs. Click here. Here you find your two variables. What you have to do is your dependent variable is smoker, you bring it to the row, and your gender you bring it to the column. Independent and dependent like this. Now go to the statistics. Here you will find out chi-square. Just click here. Another thing is phi and Kramer V. You also click upon that. I will let you know later at later part of this video why I am just clicking on this, and click continue. When I go to format, make sure this is on ascending part. Continue. Display clustered bar chart. Click OK. Yes, and then click on OK. SPSS will produce the result of chi-square test with you along with the chart. Let's discuss these results. So we have around 435 respondent. Gender male and female. This is the independent variable, and the smoking habit is the second, or you can say dependent variable, where we have a three category: non-smoker, current smoker, and past smoker. So when we use SPSS, then we have first thing that comes before us is the case processing summary. This is the first thing populated by SPSS. They showcase that in this processing summary, the total N is 435, which is my respondent. Then around 402 respondents have responded and 33 not responded. So 92.4% response I have collected out of my 435 respondents, and 33 responses are missing or not being collected or not being responded by the respondent. This is the summary populated by SPSS. Now the first thing that we want to know is association of variables, and we can find out this by using the bar chart produced by the SPSS. The bar chart says, are you a smoker? You can see that male and female, in blue is the male and red is females. So here you can see that in non-smoker category, male and female respondents are almost equal. There is no difference being a gender, being a male and female, whether you are a smoker or not, or non-smoker, there is no difference at all. Current smoker category also, you can see that there is not much difference between being a male and female or being a current smoker. Third, in past smoker category also, being a male and female is not making any much difference between these two. So here from this chart it is very much clear that the association between the gender as an independent variable and the smoking habit, which is dependent variable, is not seems to be having much association. This means that being a male or female, it is not going to define whether you are a non-smoker, current smoker, or a past smoker. So this is the first thing that we come across as a result using the chi-square. Moving ahead, the second thing or the second output populated by SPSS is cross tabulation. Here you can see what is your gender. This is in my column, male and female. Are you a smoker? So these are the three categories. 149 male and 148 females are non-smoker. No difference at all, almost same. In case of current smoker category, you can see 13 male and 24 females. So this seems to be a very little difference being male and female in case of current smoker category. And finally, the past smoker category seems to have almost no difference because 31 males are past smokers and 37 females are past smokers. So no difference at all in all across three categories. Further, the chi-square test statistics. Pearson chi-square test statistics we have calculated using SPSS, and the value of chi-square is 3.171. You can see that, and the p-value before it is 0.205. 0.205, if you multiply it by 100, that becomes 20.5%. So 20.5% indicates that this is greater than 5%, which is my alpha. So when your calculated p-value is greater than the alpha value, which is 5% confidence level, so this means that you cannot reject a null hypothesis. And what is null? Null hypothesis says there is no association between gender and the smoking habit. So this is very clear that from the graph, from the chi-square test statistics, the association between the gender and the smoking habit is not there. There is no relationship between male and being a male and female and their smoking habits. Further, we want to know a strength of relationship. How? First of all, we are aware that there is no association, there is no relationship, but still we want to know that is there any strength of relationship, how good a relationship is between being a gender or being a having a smoking habit. Let's see that. So we calculate two types of statistics for strength of relationship, which one is phi coefficient, another is Kramer's V statistics. So if the value of phi coefficient is greater than 0.8, we call it a strong relationship. If this is 0.4 to 0.8, we call moderate relationship. If it is 0.20 to 0.4, we call it weak relationship. And if it's around 0 to 0.20, we call it negligible relationship. So this is table proposed by Luck and Rubin 1992. But the problem with phi coefficient is this can only be applied when you are having a 2 by 2 matrix. This means that the row and columns are equal. What is row and column? Row and column means the variables we have independent and dependent, their categories are equal. For example, in our case, we have only two categories in case of gender, male and female. But in case of my smoking habit, we have three categories, rather two. So therefore, the phi coefficient could not be applied in our example. But what we could apply? We could apply Cramer-V statistic, because when row and columns are not equal, when row is greater than column or column is greater than row, it does not require 2 by 2 matrix, then you can apply Cramer's V. Cramer V says if your calculated value of Cramer V is near to 1, this is a strong relationship, near to 0.5 it is moderate relationship, and near to 0 it is weak relationship. So let's check that also. So we also calculated this matrix in the SPSS. As you could remember, I checked upon the free and Cramer V in the statistics tab in the SPSS. So these are the two variables, but the thing is, phi coefficient we could not consider here because we are not having 2 by 2 matrix. Therefore, I should rely upon Cramer V, and the value of Cramer V is 0.89, which is not significant. The value of P is 0.205, as you can see here. So this is 0.205 means 20.5%, which is greater than 5%. So this means that this is not significant. So how we interpreted this result? If I compare this with the Cramer-V statistics strength relationship, the value is 0.089. 0.089, and this seems to be a strong one because this is near to 1, but this is not significant. As this is not significant, it is clearly indicated that the relationship is not available there. There is neither a strong or a weak relationship, because it is very much clear from the initial chi-square test statistics that both are not having any kind of relationship. So I hope you like my video. Thank you very much for joining.